Hello and welcome everyone. Welcome to another episode. आज हम बात करने जा रहे हैं electrostatics की. And in this topic of electrostatics, we have a very special topic, and that topic is relation between electric field and potential. My name is Naveen Karki and I'll be presenting you the discussion. आज की जो class है, that will have a mixed language of communication. Will have 80% English and 20% Hindi. और class के दौरान, if you have any sort of query that you would like to put, but do remember the query should be strictly based on this, only relation between electric field and potential. या जो आज की class में हम बात करें, exclusively related only to that topic. If you have any doubt, then you may send it, but for me, only the WhatsApp channel is visible, or WhatsApp number है 9311883484. That is the WhatsApp number via which you may send your responses, you may send your query. शुरू करते हैं, talking about the idea of relation between electric field and potential. Before we start the particular concept, एक बार समझते हैं कि इलेक्ट्रिक फील्ड और पोटेंशियल के बीच में why should we find a relation, and more importantly क्या इनके बीच में ऐसा कुछ relation exist करता है या नहीं. That's what we need to find. Okay, let me repeat it again. This statement is that why do we need to find the relation between electric field and potential, and the second part is that does any relation exist between electric field and potential or not. हालांकि जो second question है, whether there is a relation between electric field and potential, इसका आंसर आपको मिल जाएगा. You can see here, because जो topic है, बात ही अगर हम इसके कर रहे हैं, so it's a common guess that yes, there is a relation between the electric field and potential. But let's talk about the primary question, that इन दोनों को हम relate कैसे करते हैं, and why is there a relation. सबसे पहली बात, electric field that's represented by E, electrostatic potential that's represented by V. All of you know this. एक है E and second is V. Now this E is a vector quantity and this V is a scalar quantity. This is what we have. You get that point? अब क्या है कि मान लेते there is a charge, हालांकि जो discussion है that's even valid for a group of charge, चाहे वो discrete हो, discrete का मतलब lots of point charges separated, or it may be a lump charge. It can be anything. Now we know around the region of this Q is there a space which we call as field. That's the first thing. Field is the region or space around a given charge. और वो जो region, वो जो area जहाँ पर the effect of this charge can be experienced. Now that's a very simple definition, और इस definition के साथ you have been doing and you have been involved with that, right? So this is the space around this given point charge where its effect can be experienced. अब ये तो समझ आ गया कि field is the area, field is the zone. But then we would like to measure the field. हम field को measure करना चाहते हैं. या more precisely, we would like to measure the strength of the field. तो इसे measure करने के लिए हमारे पास एक है vectorial technique, and that's the electric field intensity. The second is the scalar technique, and that is the potential. So one is the vectorial technique, the other is the scalar technique. और ये दोनों technique क्या कर रहा है? That is very much important. Both the techniques are measuring the strength of the field. तो यहाँ से आप देखेंगे electric field और potential दोनों कहीं ना कहीं एक ही काम कर रहे हैं, that is to measure the strength of that given charge. लेकिन the way how they do it, काम करने का जो तरीका है, measure करने का जो तरीका है, वो अलग है. One is in the vectorial way, other is in the scalar way. Now, this statement is very, very much important. Let me repeat it again. Electric field and potential, they act like a teamwork. दोनों किसी भी given charge या system of charge की strength को measure करते हैं. One measures the vectorial strength, the other measures the scalar strength. और जो vectorial strength measurement है, that is the electric field, the scalar strength measurement है, that is the potential. इसका मतलब हम एक चीज तो कर सकते हैं, इन दोनों के बीच में we can think of a relation, क्योंकि ultimately both are involved in measuring the strength of this given charge. तो शॉर्ट में लेट्स से कि इलेक्ट्रिक फील्ड कैसे डिफाइन करते हैं, पोटेंशियल कैसे डिफाइन करते हैं, लेकिन up until now the present discussion that we had, इससे एक अंदाजा लग गया, we got a judgment that yes, electric field and potential can be measured and can be related. Related would be the better word. अच्छा, measure करने का जो तरीका है वो थोड़ा सा अलग है. हालांकि एक strong difference तो है ही है. One is vectorial, other is scalar. But there is one more way how we differ. मान लेते इस given point पे, now this is very, very much important. At this given point, I would like to measure the electric field. तो हम क्या करते हैं? इस given point पे we place a point charge, to be precise, we place a test charge, and the force experienced per unit test charge, that will be the electric field at this given point. You get my point? Let me repeat it again. Is given point पे we give or we place a test charge, and the force experienced per unit test charge, that will be the electric field at that given point. यानी electric field define करने के लिए हम क्या करते हैं? उस जगह पर, कहाँ पर? Where we are interested to measure the field, we keep a test charge and we see the force per unit test charge. अब मैं मानता हूं, और I would like to see that इस given point पे if I would like to define the potential, तो क्या करें? In order to define the potential here, इसी test charge को हम infinity से यहाँ तक ले आएंगे. Now look at the difference. Define करना है उसी given point पे. जब electric field define करना है, we keep it there. इधर उधर मूव नहीं करेंगे, नहीं हिलेंगे. Exactly उसी point पे test charge को रखेंगे. We'll see the force experienced per unit test charge. That will be the electric field at this given point. But अगर मुझे potential measure करना है, if I have to measure the potential, I need to create a displacement. और कहाँ से? Infinity से. Why? By definition. और infinity से यहाँ तक we bring the charge, the negative of the work done by electric force per unit test charge will define the potential at this given point. Now, did you realize electric field measure करने के लिए we have involved force, जबकि potential measure करने के लिए we have involved work done. Let's repeat it again. In order to measure electric field, we have involved force. In order to measure potential, we have involved work done. और force उसी जगह पर निकाली जाती है, और work done के लिए we bring the given charge from infinity till that given point, and there goes the definition, the measurement of electric field and potential. So up until now, what did we do? We saw that electric field and potential can be or is used to measure the strength of that given charge. Electric field is a vectorial way and potential is a scalar way. but don't forget at the end both are used to measure the strength of that given charge. All right, so after having done this, now let's go to the next part. Let's see, calculation की बात करते हैं, because the topic that we are picking up here is the relation between electric field and potential. So I believe basic expression, the expression of electric field, the expression of potential, you know how to find that. And that's what we're going to do it, all right? Let's see. There is one charge Q, there is another charge Q, the separation between the charge that is 2A, और हमें calculate करना है electric field at this given point. ठीक इसी तरह से, for the same arrangement, we have to calculate the potential at that given point. The arrangement is same, we'll calculate electric field at this point, and in this given case, we will calculate the potential at that given point. So let's start. Let's see कि ये values हम कैसे calculate करें. As I had mentioned that I am expecting answer from you people to solve करें, and please send your answers in the WhatsApp. Please do that. Okay, some options have started coming. That's great. ठीक है. So now let me just show you that what would be the value of electric field, what would be the value of potential. अभी हमने relate करना सीखा नहीं है. Okay, we'll certainly learn how to relate them. अभी हम सीख रहे हैं how to calculate electric field, how to calculate potential. So this will act as a warm-up session for relating electric field with potential. Let's see. O पे अगर मुझे electric field निकालनी है, then that value is 0. That's 0. Reason being straightforward, because electric field is a vector quantity. तो इस Q के कारण से जितना field इधर है, इस Q के कारण से उतना ही field इधर है, and the resultant value of electric field, that's going to be 0. How about potential? Potential is a scalar quantity. So there is no question of vector addition. Or potential due to a point charge, इसका expression क्या है? The expression is KQ by R. तो अगर KQ by R एक के कारण से है और अगले के कारण से, it is still KQ by R, where the value of R is of course A. तो दोनों को अगर मिलाएंगे, we multiply by 2, and that will be the value of potential at this given point. So this was the first example जहां you learned how to calculate electric field, how to calculate potential. साथ-साथ में आप ये भी देखें, ये दोनों ही parameter, just to repeat again, the electric field as well as potential, they measure the strength of the charge or strength of the charge at the same given point, but एक vectorial way से कर रहा है और एक scalar way से कर रहा है. अब इसका physical significance क्या है? Physical significance ये है that when you place a point charge, an experimental charge at this given location, the expression of force will be 0. और एक एक्सपेरिमेंटल चार्ज को अगर इन्फिनिटी से यहां तक ले आएंगे, the negative of work done by electric force per unit test charge will be equals to 2kq by A. So just don't forget, calculate तो करेंगे, लेकिन calculation के साथ साथ you should also realize what is the utility and what is the significance of this. एक और करते हैं, all right? So here is another one. There's a square, and that square has side A A, charges are kept, Q, don't forget, minus Q. You have to calculate the value of electric field and potential. Electric field के case में, let's write something like this. The magnitude of electric field and potential at O. This is what we need to do. Yes, please. Calculate the value of magnitude of electric field and potential at O. Okay, Nilesh Drishti, आपने पुराना जो question है उसका आंसर भेजा है, but probably you must have got the answer there. और ये बिल्कुल ठीक है, that's good. Okay, now let me start. अगर हम electric field की बात करें, this given charge Q will provide electric field in this direction, and this given charge Q will provide electric field in this direction. क्योंकि ये दो charges equal हैं, the magnitude of the electric field is equal, the direction that is opposite. That's the reason why at that given point electric field due to this and this will be 0. अच्छा, अभी ये भी बचा है, due to minus Q and minus Q. The logic would remain same. Minus Q के कारण से electric field will be towards, ये minus Q के कारण से भी electric field will be towards, and the resultant value of electric field that is going to be 0. You get that point? कुल मिला के electric field at given point O, that comes out to be 0. And what is the reason for that? The reason is very simple. The values are equal and vectorially these two values get cancelled. Okay? Now after that what we'll do is see, इस number को block करें please. There's a spam happening here. Yes, block this. Okay, now let's go to the next one. Let's talk about the next point. अब हम बात करते हैं potential की. If we talk about the value of potential at that given point, अगर मुझे इस point पे potential निकालना है, you should realize that potential is a scalar quantity. और एक-एक के कारण से will calculate the potential and will add them up, right? तो बहुत ध्यान से देखें, if you see the value of potential, इसके कारण से potential जितना है, इसके कारण से the potential will be same in magnitude but opposite in direction. I misspoke, opposite in sign, not direction. Potential does not have a direction, right? जैसे इसके कारण से देखिए, that is KQ by R, मान लेते that distance is R. And even due to this, that is minus of KQ divided by R. That's how it comes. और इसके कारण से, again, you would get KQ by R. And due to next, minus KQ by R. So when you add all these given values, you get the resultant comes out to be 0. That's what it comes. Now, let's try to understand this particular thing. यहाँ पर अगर हम understand करें, the value of electric field is 0. The value of potential, that is also equals to 0. So electric field 0 है, potential 0 है. Now what you can understand is that, आप ऐसे देख सकते हैं कि दोनों 0 है, but the reason behind that is different. like electric field के केस में the value is 0 because of vector cancellation. Potential के केस में the value is 0 because one is positive, other is negative, and the value, the combined, comes out to be 0. So that was one given situation. Let's go to the next one. इसको देखते. This is a pentagon. Okay, this is a pentagon, and you need to calculate the value of potential and electric field at this given point O पे. But ध्यान देना, in this given pentagon, there are 4 charges at the vertices, and the 5th vertex that is vacant. The 5th vertex is, free. There is no other charge at that given point. Yes, please give a try. Don't forget, don't get confused. The 5th vertex that is empty. There is a question from a student. Sorry, पहले ही कहा गया है कि any question further will not be there, only related to this given topic. That will be the case, because we are catering to a larger audience. To individual question from some other, that would not be possible. Yes, please. Electric field and potential at that given point. But ध्यान देना, the 5th vertex that is empty. Yes, you may block this number as well. Even that, yes. इसको भी कर दें, please. Okay. Let's see, how do we calculate the value of electric field? How do we calculate the value of potential at that given point? Let's see how to do that. Electric field की बात करते हैं, that how do we calculate the electric field? In order to compute this electric field, हम थोड़ा सा technically चलेंगे. We'll go a bit technically. What we'll do is that इसके बजाय कि हम एक एक के कारण से निकाले and we start adding them vectorially, that will take a bit longer method. We'll go a bit trickily. आप देखिए, I will add a 5th charge at this given location. इस given point पे let me add a 5th charge and let's call that 5th charge as Q. That is what we get. इसके पीछे एक खास रीजन है, और वो रीजन ये है, we would like to play with symmetry. Symmetry के मदद से we would like to see कि एक्सप्रेशन को आसान तरीके से कैसे कैलकुलेट किया जाता है. We'll see that, okay? Of course हमें पता है we have to calculate the field due to only 4 charges, but अभी conveniently हम क्या करेंगे, we will introduce a 5th one, और फिर calculation से we'll see only the field due to 4 charges. और वो ऐसे है, देखिए, अगर मेरे पास 5 charges हैं at the vertices, for these 5 charges, the electric field due to the 5 charges at the vertex, we know that value will be 0. Right? 5 charges हैं, symmetry है, charges are equal, so the net value of electric field that will come out to be 0. But again the question is still the same, लेकिन हमसे electric field due to 4 charges पूछी गई है, only due to 4. So how are we going to handle that? I can write this as electric field due to 4 charges plus electric field due to 5th charge. The sum total is going to be 0. This given 5 charges, what we'll do is that we have divided into 4 and the 5th. और आप ध्यान से देखना, निकालना है हमें electric field due to 4 charges. So what we'll do is that magnitude of electric field due to 4 charges will be equals to magnitude of electric field due to 5th. कहने का मतलब, it may be a bit surprising, but ये जो 4 charges मिलके whatever value of electric field they are producing, that value is exactly equal to the field due to 5th charge, the magnitude at that given location. अब ये ऐसा क्यों हो रहा है? हम इस तरह से any sort of question we can't ask कि 4 बराबर 1, no such sort of fight is there. Will be equals to KQ divided by R square. So from this you could see, एक बार आप calculate करेंगे, you will do this sort of question in a very shorter step. और आप देख सकते हैं, एक certain stage के बाद this becomes almost a verbal question. और straightforward just by looking at that you can do. जबकि अगर आप इस टेक्निक से करो कि individual हर एक के कारण से निकालें, you add them, you do the vector, you find the angle between them, that's going to take pretty much of time. So you got to be, clever at each and every stage. अब बात करते हैं potential की. Now, if I want to calculate the potential, you need to understand potential हमें calculate करना है due to these 4 charges. और हमें ये भी पता है potential is a scalar quantity. While in vector, there was lots of vector cancellation, vector addition that was involved. लेकिन potential के case में, it's a straightforward game. Because the addition is scalar, we find it very easy. जैसे, due to 1, that is equals to KQ by R. Due to this, KQ by R, KQ by R, KQ by R, यानी 4 के कारण से, the value will be 4 KQ by R. So that is the simplicity which comes when we start calculating potential. Now this particular example is a very, very beautiful example. This will teach you how to deal with the vector quantity. This will also teach you how to deal with the scalar quantity. और दोनों के जो approaches हैं, they are a bit different. So you got to be clever in this. और एक interesting बात ये है, जो भी आप electric field और potential के बारे में सीखेंगे, the same sort of concept exactly it's valid even in gravitation. तो होता क्या है, one effort, but that's going to be utilized in both the cases. So in that way, this becomes quite an important stuff. Now let's go to the next one. Going to the next one is this. There's a term which is called as gradient. And now let's try to understand what is the meaning of gradient and how do we, utilize this. Up until now, हमने क्या किया? We have seen how to calculate the electric field, how to calculate the potential at a given point. अब हम धीरे-धीरे इस चीज के ओर बढ़ रहे हैं, that how can these two electric field and potential be related. ये जो दो parameters है, electric field and potential, how can they be related? और वो जानने के लिए the first and foremost thing that you require is gradient. Now gradient is a very, very important term. If it's students who are NEET aspirant, वो तो कभी maths करते नहीं है 11th 12th में, so there is no question. But students who are JEE aspirants, उनके लिए you need to understand gradient is a term in calculus, but you would not be doing this term in your class 11th 12th syllabus. ये generally higher mathematics, preferably in engineering or higher mathematics जो pursue करते, they study about gradient. But what we'll do is that in a short steps हम gradient को एक बार understand करते हैं. Let's try to understand how, what is the meaning of gradient. First of all, guys, you need to understand this gradient is a mathematical operation. Now, what sort of operation? It's not that, doctor operation with the scalpel. It's not that. It's a mathematical operation. जैसे कि it can be a derivative. It can, जैसे derivative is an operation. Integration is an operation. उसी तरह से gradient, that is also an operation. Okay, तो अभी के लिए आप ऐसे मान लो, it's very similar to derivative, very similar to integration. जिस तरह से they are a process, this is also a process. Okay, now after this, gradient जो है, that is always taken on a scalar function. इसका मतलब you can have gradient of scalar, but you will not have gradient of vector. इसका मतलब you can have speed gradient, but you don't have velocity gradient. You can have temperature gradient, you can have pressure gradient, but we don't have acceleration gradient. We don't have, कोई भी एक vector उठाइए, force gradient, we don't have. We only and only have the gradient of a scalar quantity. That's the first thing. और gradient को हम इस तरह से represent करते हैं. The opposite triangle T. Like if I say this T is a temperature, ये जो expression है, this is what we call as temperature gradient. या आप gradient of temperature. Anything you say, that's equally fine. Okay? But another interesting thing is that gradient is always taken for a scalar quantity, but वो operation करने के बाद the quantity gets converted into vector. Now this is very interesting. Like in the previous discussion we said gradient is always taken for a scalar quantity. Yes? But जब आप gradient लेते, when you perform that operation, अभी तक आपने सीखा नहीं है what sort of operation is that, but we can understand in that way there is something. When you do the gradient of a scalar quantity, the outcome जो मिलता है, that's a vector quantity. So gradient of a scalar is vector. That is what you get. Another thing is that, say, direction of gradient at a point. Now this is very, very much important. कि एक चीज तो आपको समझ आ गया that gradient का symbol ये है, gradient of a scalar is a vector. That much we have understood. You get that point? One thing we have understood that gradient is taken for a scalar quantity and gradient of a scalar is a vector. यानी अगर कोई भी gradient हो, like it can be for example 2i cap plus 3j cap, any given thing, okay? This is something, the value which is a vector quantity. अब अगर vector है, it will have direction, और अगर vector है, you can find the magnitude of that vector as well. तो आइए understand करते हैं that how do we find or what is the meaning of direction of a gradient and magnitude of a gradient. Let's try to understand that. ये understand करने के लिए एक काम करते हैं. Let's take a simple function and this is going to be very interesting. Let's take a simple function. Let us say temperature. Okay. ये example को ध्यान से understand करना. This is really going to improve your understanding to a very great extent. So there is a quantity which is temperature and this is a scalar quantity. अब अगर इसके gradient हम लेते हैं, this will convert into a vector quantity. You get that point? So what does that mean? Let's try to understand. Let us say this is a room, okay, and इस room के इस wall पे there is an air conditioner, the AC is there. Now overally जब हम temperature of room कहते हैं, we take an average value of temperature of the room. हालांकि अगर हम precisely देखें, at different coordinates of the room, the value of temperature that is different. Now let's try to take a simple example. मान लेते यहाँ पर there is a temperature 40 तो ज़्यादा होगा because the air condition is there. So let's say is 22 degrees centigrade is the temperature at this given point. Okay, किसी और जगह पर temperature की value is something different. Now if I travel in this direction, in this direction, in this direction, suppose I travel and I travel the same distance, okay, ऐसा नहीं है कि यहाँ आप ज़्यादा करें यहाँ कम करें, every possible direction you travel the same distance. In that given case, suppose in this direction temperature falls by -2 degrees centigrade. In this direction temperature falls by -1 degree centigrade. And in this direction, let's say the temperature falls by -3 degree centigrade. What have we done? We found the temperature at a given point. और कर क्या रहे हैं? We are trying to see the meaning of temperature gradient. And again, is it eligible? Yes, it is eligible because temperature is a scalar quantity और जो gradient लिया जाता है, that's always taken for a scalar quantity. तो यहाँ है temperature 22 degree centigrade. Okay, that's just for an example. And we traveled same distance and then I found कि there is a specific direction, एक specific direction है जिसके along the temperature falls by maximum value. Let me repeat it again. There is a specific direction along which temperature falls by maximum value. तो वो जो direction है, कौन सी direction? जिसके along temperature falls by maximum value is the direction of gradient. So that is the significance of direction of the gradient. Interesting है ना? That's quite wonderful. So again, because I know the topic is a bit heavier, so let's try to recollect everything और दोबारा एक understanding देखते. Gradient is always taken for a scalar quantity. So we, for the sake of example, we took a temperature scalar quantity और हम temperature gradient को understand करने की कोशिश करते हैं. Now, overall gradient is a vector quantity. So it will have its direction, it will have its magnitude. तो हम जानना चाहते हैं what is the significance of direction of temperature gradient. So we saw कि जो भी direction of gradient है, that is the direction along which the temperature falls by maximum value. अब इसको rise में भी कर सकते हैं. If you see that it's a rising function, gradient direction is that direction along which temperature rises by maximum value. Okay? So direction के बारे में we have understood. Now we would say what would be the magnitude of temperature gradient. What does that signify? जैसे कि आप यहाँ देख सकते हैं that suppose if someone says this is -3 degrees centigrade per centimeter. इसका मतलब this is the rate how temperature changes. यानी for a distance of a centimeter traveled, temperature decreases by -3 degrees centigrade, but there is a very important catch कि आपने 1 centimeter travel किया और temperature fall जो है वो 3 degrees centigrade है, but the most important thing is that along which direction will you get the fall rate of this much? Along the direction of the gradient. कहने का मतलब उस given point पे if this is the direction of gradient, if you travel 1 centimeter along the gradient, not in other direction, the temperature falls by 3 degrees centigrade for every centimeter for this given expression. So it becomes a very very lovely expression. और gradient हमें बहुत सारे चीजें बताता है. Like again, for the final conclusion, if you have a scalar quantity, you take its gradient and make it vector. So for example, temperature is a scalar quantity. You take the gradient of temperature, it becomes a vector. और उस vector की जो direction है, that signifies that direction along which temperature decreases or increases at a maximum rate. और उस direction में अगर आप travel करोगे, the rate at which temperature changes is given by the magnitude of gradient. ध्यान देना, magnitude of gradient अगर 3 degree centigrade per centimeter है, इसका ये मतलब नहीं है that in any direction of 1 centimeter temperature falls by 3 degrees centigrade. That's wrong. The temperature falls by 3 degrees centigrade if you travel along the gradient. So that becomes a very very important point. So I hope now with this much of discussion you are completely comfortable with the idea of gradient. Okay. आगे बढ़ते हैं. Let's see how do we calculate the gradient. इसमें computation of gradient we do. One is in Cartesian coordinate system, other is in spherical coordinate system. Cartesian coordinate system में this is that function which is a scalar quantity जिसके gradient हम calculate कर रहे हैं. Alright? So the entire thing is that gradient of the given function. Now this is how we do. अगर आपके पास, see, how do we read this entire expression? Gradient of f, and that f is a scalar quantity. आप देखिए, first we have done the partial derivative of f with respect to x, and we have kept I cap. Second is partial derivative of f with respect to y, and that's what we call as j cap. Partial derivative of f with respect to z, और साथ में हम रखेंगे k cap. Now another assumption I have to take that you know how to calculate the partial derivative. Okay, so partial derivative of f with respect to x, don't forget to attach I cap. Partial derivative of f with respect to y, j cap. Partial derivative of f with respect to z, and k cap. Let's take an example. Let me say that the function is x cube y z square. This is the given function. कोई एक scalar function है. It really doesn't matter कि वो क्या है, but what really matters is that this given function is a scalar quantity. Now I would like to calculate the gradient of this function. तो पहली चीज, partial derivative of f with respect to x. So this comes as 3x square yz square, और साथ में लिखेंगे I cap. For those of you who don't know what is partial derivative, it's quite simple. With respect to x जब करते हैं, all other except x are constant. जैसे आप देखिए, yz square, x cube का जो derivative है, that's 3x square. Further, अगर हम करें partial derivative of f with respect to y, I will get x cube z square, ये constant है, और partial derivative of y with respect to y is 1, और यहाँ आ जाएगा j cap. और बारी है आखिरी del f by del z, that is, अब इसमें बस z square, that is the variable, rest all they are constant. तो आ जाएगा x cube y multiplied by 2z of k cap. So I hope with this particular discussion you can calculate the gradient of any given function. इसे आप एक mathematical exercise के तौर पे माने. Certainly we'll see its application to physics as well. Okay. अब बात करते हैं spherical coordinate system में. This spherical coordinate system अभी के लिए as a class 11, 12 students जो mathematical background जिनका है, आप okay, one more example. Let's go for this one. One more करते, okay? So this is something like this. F equals to, let's say, x cube y plus of z square. And I want to find the gradient of this function. So if I want to calculate the gradient of this function, definition लिखते हैं del f by del x I cap plus del f by del y j cap plus del f by del z k cap. So this is the partial, the entire gradient, and these are respectively the partial derivative. Del f by del x, if I see that, वो बन जाएगा 3x square y, the derivative of x cube, 3x square y, क्योंकि जब आप x के respect में, when you go for the partial derivative, you will just consider x as the variable, rest all would be constant. तो y constant है, x cube का जो derivative that's 3x square, और z square का जो derivative है that will be 0. So multiplied by I cap. आगे देखते del f by del y. यहाँ देखते कि when you are partial derivating it with respect to y, y is the variable, so x cube is constant, that will be x cube, or z will be constant, so the derivative will be 0. And ये बन जाएगा j cap. और बचा del f by del z, इसको जब हम differentiate करेंगे, the constant xy constant बन जाएगा, z square का जो derivative है that's 2z multiplied by k cap. तो इस तरह से कोई भी given function हो, you can calculate the gradient of that given function, and as I said, if you take the gradient of a function, that scalar quantity that becomes a vector. और gradient के बारे में we have already seen in detail. You know, normally books में आपको gradient के बारे में उसके जो physical meaning है, interpretation है, you find it less. So I have ensured that we discuss maximum about the gradient which we have done. Right? Okay. अब spherical coordinate की बात करते हैं. You will not be getting anything in a direct spherical coordinate manner. There is a small misprint here. That's equals to r. Okay. तो आप देखना. Spherical coordinate system, polar coordinates. You can see in that way. Spherical coordinate में we have r, theta and phi. Now this is exactly by the definition. R, theta and phi. That's what we get. लेकिन आपको इन सभी जो expression है, इन पे ध्यान देने की जरूरत नहीं है. You just concentrate only this much, which is more than sufficient for JEE and NEET syllabus. तो फिलहाल के लिए spherical coordinate system में you take this del f by del r multiplied by r cap, because anyway other functions, ये जो parameter, when you solve this, that will come out to be 0. Okay, so this is what we talk about the expression of gradient. Now let's go to the next point. अब बात करते हैं कि अगर potential given है, now we are coming to the point, कि अगर आपको potential की value दी गई है, then from that given value of potential कि हम electric field कैसे calculate करते हैं, that is the main thing. Given V to find E. इसके बाद we'll also do the reverse of the case, कि अगर हमें electric field दी गई है, how can we calculate the potential? Both the things we are discussing, and do remember both the things are very, very much important. सबसे पहली बात देखिए, इलेक्ट्रिक फील्ड इज माइनस ऑफ ग्रेडियंट ऑफ V. नाउ विल टॉक अबाउट अदर थिंग. आप बहुत ध्यान से देखिए, ग्रेडियंट ऑफ V that has been said. इसका मतलब the very existence of electric field lies in the fact that the potential is changing. Let me repeat it again. The very existence of electric field lies in the fact that the potential is changing. इसका क्या मतलब है? Let's try to understand that. जैसे कि if you say that there is acceleration, तो आपको ये बताने की आवश्यकता है ही नहीं that velocity is changing. Let me repeat it again. You say that there is acceleration, so there is no point to say that the velocity is changing, because the very existence of acceleration is a proof, is a testimony that the velocity is changing. Exactly in the same manner, electric field is minus of gradient of V. So gradient मतलब derivative is involved, change is involved. तो जहां potential में बदलाव है, wherever the value of potential changes, there you get the electric field. अगर potential की value constant है, जरूरी नहीं है zero constant हो. If it's a non-zero constant as well, the value of electric field comes out to be zero. So do remember, the very existence of electric field lies in the fact that potential is varying. And how do we calculate it? We calculate it as minus of gradient of potential. और negative sign हमें ये बताता है that electric field is directed from high potential to low potential. Let me repeat it again. It says that electric field is directed from high potential to low potential. इस context में we come up with a very very interesting question. मान लेते this is the field lines, all right? And let's say that this is how the field lines are there. मान लेते this point is A and I call this point as B. Now if I ask you, between point A and B, electric field का जो magnitude है, where is it greater, at A or B? तो हम क्या करते हैं? Field lines में we see the crowdedness of the line. जहां line ज़्यादा crowded है, electric field stronger है. तो यहाँ और यहाँ देखेंगे, the field lines is more crowded at this given point, so electric field at B is higher than that at A. That's our first job. So, you know, this is a very simple fact, but एक बार recollect करते हैं, because just to avoid any sort of confusion that may happen. अब अगर मैं potential of A और potential of B की बात करूं, तो कहां potential ज्यादा है, कहां कम है, वो जानने के लिए we simply look at the arrow of the field lines. आप arrow देखेंगे, that's going from left to right. Because the arrow is going from left to right, potential at A is greater than potential at B, and that is the significance of negative gradient. That is the meaning that field lines is directed from high potential to low potential. That is this particular meaning. Okay? Field lines are directed from high potential to low potential. So quite interesting things coming out right here. Now, as I said, electric field is always associated with change in potential. तो एक काम करते हैं. Let's try to understand some more thing. There is a very important thing जिसको हमने लिखा है, electric field is 2I cap. Let me just try to tell you कि इसका significance क्या है. First of all, आप 1,2 में जाइए. You go at 1,2. और वहां से you try to travel in every possible direction. Suppose you reach at point 1,2 और आप हर possible direction में travel करें, तो आपको दिखेगा potential changes, potential varies. But इसको एक बार आराम से बनाते हैं. Let me do in this way. Let's come here. जैसे आप 1,2 पे जाए, let me just take a few points, okay? इधर जाए, इधर जाए, इधर जाए, इधर जाए. कहाँ से? 1,2 से. Why? Because the value has to be, decided at this point. So at different location, different direction, the value of potential changes. लेकिन electric field is in the direction of 2I cap. इसका मतलब x-axis के along, y-x, because the electric field is 2I cap. And what is electric field? Gradient of potential. इसका मतलब along x direction, the potential changes at maximum rate. This is what you get. This is what you get. इसका meaning ये है. Remember, the all meaning and the all study of the gradient, whatever we have done so far, will come to the application and utility here. What did we do? कि पहली बात तो electric field 2I cap, so this is the negative gradient of potential. इसका मतलब you come at 1,2 and you travel in every possible direction, you would find a very interesting fact कि जब आप x के along move करेंगे. Why? Because here the potential changes. Don't say the electric field. It's a gradient of potential. So potential changes by a maximum rate. And what rate? That is 2 volt per meter. यानी बाकी direction के बारे में I don't know, I need to calculate it, but एक चीज है 1,2 से if I travel along x direction, you would see the value of potential changes at maximum rate, and that given rate is 2 volt per meter. तो आप देखिए, just from a simple fact, simple expression, so many beautiful things we get. So you have to be, very vigilant. और आप देखेंगे, it's something entire operation कि हमने unassemble कर लिया, assemble कर लिया about electric field and potential. Okay. Now, guys, let's go to the next one. दूसरे में चलते हैं. One more thing, let's try to see. Let's try to understand. Okay, suppose now I have been given that this much is the electric field, 2 volt per meter. Now, if I start here, मान लेते, I start here. If I go towards right, first of all, the potential decreases. देखते हैं कि इससे हम क्या-क्या meaning निकाल सकते हैं. So many different meanings are there. We'll try to find out. If I travel against the field, then the value of potential increases. So that's another fact. So इसका यही मतलब है that if I travel along this direction, the value of potential that is constant. You get that point? Along one direction, it is decreasing. Along other direction, it's increasing. Direction of what? Don't forget, direction of electric field. And in perpendicular direction, the potential is constant. That's first fact. Now, the second fact is that you need to understand one thing. Okay, where's the tool? Here. अगर मैं travel करूं in this direction, if I travel in this direction, then potential decreases by 2 volt per meter. You need to understand that. कि अगर मैं electric field की direction में if I travel, the potential decreases by 2 volt per meter. लेकिन if I say, what if I travel 1 meter along this direction, which is 60 degree. अगर तो मैं 1 meter इस direction में travel करूं, that we have already seen, potential decreases by 2 volt for every meter traveled. What if I travel in this direction? अभी भी आप देखेंगे potential will decrease, क्योंकि effectively we are traveling along the electric field. but by how much? That will be 2 multiplied by 1 cos 60. और ऐसा क्यों? Because you can see the effective distance along the electric field is only 1 cos 60. That's what you need to understand. The physical distance, no doubt, is 1 meter, but we got to see what is the effective distance along the electric field, और उसकी जो value है, that is 1 cos 60. So here you get this as 1 volt per meter. That's what we get. So just see what interestingly we got कि अगर मैं electric field के along travel करूं, for every meter traveled, potential changes by 2 volt, and for every meter travel in this 60 degree, the potential changes only by 1 volt. और reason यही है, because the electric field is the gradient of potential. So potential changes by maximum rate if I travel along the direction of electric field. So hope this thing will really simplify your understanding. So here is a question. अब एक numerical करते हैं कि electric potential in this space is given by this much. X, Y, Z, they are in meter, और आपको calculate करना है, बहुत ध्यान से question पढ़िएगा, केवल Y component of the electric field, and that too at this given point. So please calculate. Okay, so let's see, इसे solve करते हैं. निकालना क्या है? Only the Y component. So the Y component of the electric field is minus of del V by del Y. That is the Y component of the electric field. Yani I have to go with the partial derivative of V with respect to Y. बारी बारी से करते हैं. Minus 2. And the technique was this. Y is variable. Rest all are constant. तो यहाँ पर we'll use the sum rule. Y is variable, X is constant. So X ये आ जाएगा plus of 2YZ plus of X square Z. क्यों? Because आप देखिए Y variable, X is constant. So that becomes X. यहाँ आप देखेंगे Z is constant, derivative of Y square is 2Y. और यहाँ देखेंगे X square Z is constant, derivative of Y is Y. तो ऐसा करने से we have calculated the Y component of the electric field. You get that? Now after this, this comes out to be equals to minus 2. Let's put the value. The value of X, which is 3, 2YZ, which is minus 4, X square Z, that will be 9. So देखते how much will I get? That's 12 minus 4 is 8 to 16. Let's see, 3 comma minus 2 comma 1. एक बार check करते हैं whether there is an option or not. We've got to calculate the Y component, right? Del V by del Y. So that's 2X, 2YZ plus X square Z. Perfectly fine. X is 3. Y is minus 2. That's minus 4. Z is 1. X square Z. So that's going to be 9. So this will be 12 minus 4 is 8 minus 2. So that comes out to be minus 16 Newton per coulomb. I feel that the option has a mismatch. तो इस तरह से we calculate about the कोई भी कंपोनेंट आपको चाहिए, x component, y component, z component or the total value of electric field, this is how you calculate it. Let's proceed further. आगे बढ़ते हैं. अब आप देखिए V is kq by r and I have to calculate the electric field. Look at the expression. अगर आप expression को ध्यान से देखेंगे, you could see that it is given in polar coordinate manner. Potential as a function of r, so this is in a polar coordinate. So let's try to calculate. और बहुत ध्यान से देखना, ये जो expression है, this is the expression of potential due to a point charge. तो ये जो question है, this will help us to validate the result कि E is minus of gradient of V जो हम कहते हैं, you know, it just gives a back testing of that particular expression. Okay, so let's see. E is minus of del V by del R multiplied by R cap. जहाँ आपको पता है, symbols have the usual meaning. R cap is in the radially outward direction. और अगर minus R cap है, that will be in the radial inward direction. Let's go for this. That comes out to be minus of del by del R, और V के बदले में we'll write KQ by R multiplied by R cap. Further, you could see something like this. That is equals to minus of KQ. This comes as minus 1 by R square multiplied by R cap. This is what you get. Quite simple. 1 by R का जो derivative है, that's minus 1 by R square, and this comes out to be KQ by R square multiplied by R cap. यहाँ से आप देख सकते हैं. We started with the expression of potential due to a point charge, and then we got the expression of electric field due to a point charge. Numerical करने से पहले we had said that ये एक back testing की तरह काम करेगा. We know that the expression is correct, but just to validate, just to see the validity of the expression, that is the given part. Let's move further. हमें calculate करना है the value of electric field at R equals to 3.5. तो ये आपको एक graphical exposure देगा, this given question. The variation of potential with respect to R that has been given, और आपको calculate करना है the value of electric field at R equals to 3.5. Yes, please proceed. Okay, let's see. आप देख सकते हैं that between 2 to 4, because that point 3.5 lies here. So that point 3.5 lies here. So between 2 and between 4, अगर आप देखेंगे, the value of potential is constant. And if the value of potential is constant, minus of del V by del R multiplied by R cap, that will be equals to 0. Yes, that will be equals to 0. So option number 4, that comes out to be correct. All right, let's move further. आगे बढ़ते हैं. अब हम opposite कर रहे हैं. अभी तक हमने देखा that if potential is given, then how can electric field be calculated? अब हम reverse कर रहे हैं. That अगर हमें electric field दिया गया है, then how can we calculate the value of potential? इसमें एक चीज मैं आपको बता दूं. that directly we can't calculate potential. Electric field की मदद से we get the potential difference. Let me say again, if you have electric field, then you get the potential difference. और अगर कोई point reference के तौर पे दिया गया है, then certainly we can calculate the potential. Of course, the potential at reference, that is 0. तो कैसे calculate करेंगे? Here is the idea. dV, there is a minus sign missing here, minus of E dot dr, that is the expression of potential difference. dV minus E dot dr. ये basic idea वही है. अगर आप देखेंगे जिस direction में electric field है, आप बहुत carefully देखिए, you would find this as minus E dr cos theta. Negative sign को आप completely ignore करें. Ignore मतलब ऐसा नहीं है कि आप नहीं लिखेंगे, but for interpretation, you know that negative means that electric field is directed from high potential to low potential. That's the significance of negative sign, nothing more than that. But आप बहुत ध्यान से देखिए, what is theta? Theta is the angle between E vector and dr vector. And what is dr vector? That direction along which we are traveling. तो आप देख सकते हैं, if theta is 0, dV will be maximum. Let's repeat again. If theta is 0, dV will be maximum. इसका मतलब, if I travel along electric field, the potential changes by maximum rate, जो कि आप यहाँ से भी देख सकते हैं. If theta is 0, that will be 1, dV will be maximum. यानी आप अगर same dr से अलग-अलग direction में travel करें, then dV, the change in potential, will be maximum when theta is 0. That means if you travel along electric field, the potential changes by maximum rate. आप देखिए कहीं ना कहीं again the whole idea of gradient that is emerging, and that's a reason why at the beginning of the class we talked about the concept of gradient in a greater detail. And next is this. इसी चीज को अगर हम कार्टेशियन फॉर्म में लिखे, माइनस ई डॉट डी आर, इलेक्ट्रिक फील्ड ई एक्स आई ई वाई जे ई जेड के, डी आर डी एक्स आई, दैट एक्स इज दिस, ये कैपिटल, ये सबस्क्रिप्ट नहीं है. ओके, लेट मी डू समथिंग लाइक दिस. दिस इज डॉट ऑफ डी एक्स आई कैप प्लस डी वाई जे कैप प्लस डी जेड के कैप. दैट इज द गिवन एक्सप्रेशन. So let's see with the question. All right, let's try to understand. To understand that, let's see. Here's a question. आप कर लीजिए एक बार. Electric field exists in a space as this much. Find the potential difference between points A and B. Try out. Okay, Ras Kamal, you had sent an answer. Good, very good. Okay, answers have started coming in. बाकी भी भेजिए. Let me wait for a couple of more. Okay, -5 is what Raj Kamal says. Check करेंगे अभी. Some more, let's see. हालांकि मुझे आंसर नहीं बताना चाहिए था, but चलो, it slipped off. Okay, हमें calculate करना है potential difference between A and B. So we start in this way. dV is minus of E dot dr. And we'll put the limit. RA, this is VA, RB, and this is VB. So that's how we'll put the limit. Be careful, dV is minus E dot dr. Then I get VB minus of VA is equals to, if I go for VB minus VA minus of integral E dot dr, that will be 2I cap plus 3J cap plus 0K cap dot. We'll have dx I cap plus dy j cap plus dz k cap. This is what we have done. Okay. Further, let's see. Okay, how can I forget that? नीचे limit of RA, ऊपर limit of RB. Why? Because we're doing VB minus VA. Now, let's see, इसको एक step में करते हैं. देखिए, -2. Okay, let me do it for you. -2 dx plus 3 dy minus will come outside. So this is minus and limit. अब देखते हैं. If you see the upper limit is for B, the upper limit में x limit is y1, y limit is 1. नीचे देखेंगे 2, 2. That's how it goes. Furthermore, इसे solve करते अब, I would get this as -2 dx, that becomes 1 minus 2. Okay, that's a big minus there. And wait a minute. This is getting something like that. चलिए इसको एक काम करते हैं. It's a simple integration now. Minus, ये बन जाएगा minus of 2 because 1 minus 2, और ये बन जाएगा minus of 3. So that comes out to be 5. So ऐसे question में there is always a chance of making mistake for a negative sign. So just be careful. Just be careful. The option here comes out to be 2. So Ras Kamal, you just rectify yourself. यहाँ पर ध्यान देना, एक minus sign पहले, and because it has said VB minus VA, so therefore upper limit B, lower limit A. So this is how we can go for the calculation. All right. Okay, now let's go for the next one. इसे एक बार देखते हैं. Let's try to understand. You know, a couple of things have been added here. So since I'm falling short of time, let me start discussing. The electrostatic potential difference between A and B, that's what we have to calculate. Which are at distance, A की दूरी, B की दूरी दी गई है, और किससे? From an infinitely large thin plate. So it's something like this. This is an infinitely large thin plate, and it has a density which has been given sigma, and that is 1 millicoulomb per meter square. So of course we can calculate that. इसको suitable SI unit में we can change. Now you know that the value of electric field due to infinitely large sheet, that is equals to sigma by 2 epsilon naught. तो ये जो given question में you could say multiple things have been used. एक तो आप electric field, you use it from the standard expression. ठीक है? और किन किन के बीच में निकालना है? RA and RB. So here's the case. This is VA and this is VB. एक काम करते हैं. Because the electric field is constant, okay? So instead of going into formality, let's try to see how faster we can solve it. अब देखिए, this is at low potential, this is at high potential. How come? Electric field is directed from high potential to low potential. तो अगर VA minus VB ये पूछा गया है, that will be negative. So in that regard, option number 1 and option number 3, that will be eliminated. Right? Because A will be at low potential, B would be at high potential. Or this is a case of what? Constant electric field. तो इस केस में the difference in potential VA minus VB, that's going to be minus sigma by 2 epsilon naught, and the separation between them, that's equals to 1. Rest आप easily solve कर सकते हैं. You just solve it, you will get the answer. Sigma by 2 epsilon naught, don't forget, is the electric field. So I need to wrap up and wind up my session. Today's one, it was a very nice discussion that we did. First we saw electric field or potential एक given charge configuration की properties है. And we saw that how cleverly we can relate these two property. Though एक vectorial है, एक scalar है, but there are techniques how we can relate, and we did that, right? और उसी सिलसिले में we learned about a very interesting thing that was called as the gradient. And we saw the significance of the gradient in terms of its direction and in terms of its magnitude. I'm pretty confident you'll carry this further. So it's time for me to sign off. I'll catch you up in the next one. Take care. Thanks for joining. Bye for now.